First of all, now metals. So metals in the periodic table means the things that will form positive ion. They are known as metallic nature. Okay. The one that when they form ions, their ions are having plus charge. Like starts from lithium, sodium, potassium, so on, so on. So these all form plus charges, like lithium forms lithium plus. Similarly, magnesium forms Mg2 plus. Moreover, all the things in the periodic table that ends with IUM, they are metals. Okay. Other than this criteria, there are metals, but all the things, maximum things, there is an exception of selenium, but maximum things ending with IUM are metals. So you can start seeing their names from here. Like see, lithium ends with IUM, sodium ends with IUM, potassium ends with IUM, rubidium, cesium, francium, everything. So these all are metals. Now we have non-metals. Non-metal means the things that form negative ions. Okay. So the non-metal starts with this carbon. These only this segment of the periodic table contain non-metals. Like that's it. Okay. So you can just learn them also. Like they are like 1, 7, 8, 9, 10 are in number. Just only we have just 10 non-metals in the periodic table. 80% of the periodic table is metals, and rest few, these pale green colors, these are semi-metals. So do you know what is a semi-metal?
No.
Okay, semi-metal means the one, see the word semi, it has the word semi. So the semi means they have the properties in between metals and non-metals. Sometimes they can show a metallic behavior, and sometimes they do show a non-metallic behavior. That is known as semi-metals. Okay.
Oh.
So the other name for like these semi-metal is metalloids. So either you call them as semi-metals or metalloids. Okay, metalloid is also the same.
Oh, metals. Oh.
You must be aware of this word.
Yeah.
Okay, then it's fine. So metalloids are semi-metals. Okay. So next, if you see this extension of the periodic table, which has like this gray-black color. So these are, what are they?
I don't think I've seen them in my. Wait, let me. No, I don't know. Can I say?
Sir, for like your, they don't ask you this in your IGCSE, but I'm just telling you, these are also metals, but these are man-made metals. Okay, they are not occurring in nature. We just generated them in lab, so we are adding them in the periodic table. That's it. Yeah, the important segment that you need to know is this one: thorium, this, plutonium, uranium. So this segment of the periodic table is radioactive. Now, what do you mean by radioactive?
It it can how do I it's very toxic.
Okay. Yeah, makes sense. Very toxic. So, because in the metals, now what you have done, that blast furnace one, there you need to know the reactivity of the stuff. Because we have several things related to reactivity, like how to get a pure state of element and stuff. So, see, so do you know the shell structures of the metals?
The shell structures of metals.
Any atom, if you don't know the, like, if I say sodium, sodium has 11 electrons. What is the structure of sodium?
11. Okay. Then there's only 3 shells.
Okay, yeah, perfect. So number of electrons in shell 1
Yeah.
are how many?
A valence shell.
Yeah, you
Wait,
can. Yeah, valence shell. Tell me valence shell.
the valence shell is 1.
Correct. Perfect. Very good. Yeah, the valence shell in the sodium is 1.
Mm.
So let's now draw the structure of lithium, sodium, potassium. So lithium is like this. 2 in the first,
8.
and
What's the? I don't remember.
this is 3, this is 11, and this is 19.
Oh, okay.
So next we have sodium. So sodium would be 2 here, 8 here, and 1 here. Correct?
Yes.
And what would be potassium?
There'd be 4 shells.
Perfect. So 2, 8, 8, and 1. Correct?
Yes.
So see, now we have to define reactivity. Okay, reactivity means how easily they can lose electron. So first of all, reactivity in case of metals is defined as how easily they lose electron. Okay, you need to remember one thing. Whenever they are losing electron, they will always lose the valence electron, not the inner electrons. Okay. Okay, the electrons present in the valence shell are subjected to lose, not the other electrons. So in lithium, how many electrons are there in the valence shell?
1.
So in lithium can lose just 1 electron. Similarly, sodium can lose 1. Potassium can also lose just 1 electron. But now we have to arrange them out of lithium, sodium, potassium, which would lose the electron easiest and which would be hardest to form a positive ion. See, in the center, the structure of the atom is like in the center, we have nucleus, correct? We have nucleus in the center and the electrons revolve around the shell, correct? This is the structure of atom. Sure. Tell me, what is the structure of atom?
The structure of this